Test.
Testing 1, 2, 3.
One, two, three.
Good evening, everyone. My name is Philip Craig, and I'm honored to serve as the rector of St. James Parish. On behalf of our parish family, and especially our St. James Speaker Series Committee, I welcome all of you to our gathering this evening. Truly, we are delighted to be back in person and to have all of you here with us tonight. Your presence is important. The Reverend Pamela Conrad is an Episcopal priest and the rector of St. Albans Parish in Glen Burnie, Maryland. She serves as the chair of the Truth and Reconciliation Commission for the Episcopal Diocese of Maryland, a group charged with working on racial reconciliation, truth-telling, and transformation. She also serves as the warden for the North American province of the Society of Ordained Scientists, of which I'm not a member. I'm sorry.
We're always looking for more members.
Impressively, she's also an astrobiologist and a planetary scientist in understanding how planets, specializing in understanding how planets do or do not evolve into habitable environments. She's presently involved in the exploration of Mars with the Perseverance rover and its companion, the Ingenuity helicopter. As my 14-year-old daughter would say, that's awesome. Pan has an appointment as a research scientist at the Earth and Planets Laboratory of the Carnegie Institution of Science in Washington, D.C. As both a priest and a scientist, one of her priorities is to help people feel confident to engage both their critical thinking and their faith in all aspects of life, using what we can learn from exploring nature as an approach to understanding the relatedness of all that God has created. Awesome indeed. Please join me in welcoming tonight's St. James Speakers Series guest, Pan Conrad.
Thank you so much. And thank you all for coming tonight. I am delighted to be here. And I will say that in the general sense, everything that exists is pretty awesome, even during Lent. So I'm going to talk a lot about dust tonight, because it's kind of been on our minds every Sunday. At least I say it several times this Sunday. One of the most amazing things about the entire universe is it's made of dust. So it's not just we who are dust and will return to it. Everything is, and it started out that way as well. And so one reason why Lent is extra special, if you're a cosmologist or a planetary scientist, is because everybody's talking about dust. One of the things that I think is remarkable about our faith tradition is we also talk a lot about redemption. Now, when I was a little girl, redemption had a very particular meaning. When we went to the grocery store, at the checkout, you got these stamps. I remember there were some green ones, there were some pink ones, and my favorite ones in the DC area were the yellow ones, the top value stamps. And you could paste these into a little booklet and then trade in the booklet and get something really cool, like a football uniform. Which, although my parents said it was unladylike, I did redeem said football uniform and used it in the neighborhood games to protect myself. I can't name names because we're live streaming this, but you know who you are. So I began to think about redemption as trading in one thing for another thing. Later on, I began to hear about redemption in church as something sort of like rescue. We talked about salvation and redemption as being co-equal things. I began to push back on that because I thought that redemption is probably a lot bigger if it can also include a football uniform. And so I started to think about redemption in terms of its meaning to fulfill the potential of something. To fulfill the potential of something is very broad. It has a much bigger meaning than sin, I began to think about the ways in which good things can turn into bad things, and bad things can turn into good things. And I began to think about how often those giant events, which we call cataclysms, can actually be redeemed and produce a good result. It may not happen in the time frame that we'd all like it to happen, but it can happen. So I've been thinking over the last several years, actually for about 10 years, about all of the major catastrophes that have occurred since God began making the universe, and how each of these catastrophes has actually been traded in for something new and amazing. So talk about awesome, the ability to redeem something truly awful and turn it into something truly wonderful is the thing that makes me want to get up in the morning. There isn't enough awfulness in the world that could convince me God cannot redeem it. So tonight I want to talk to you about some of the things that have happened in a broad cosmological sense that God has been able to redeem for us. As a scientist, I find this tremendously exciting. As a person of faith, I think, well, of course. It's important to hold this concept closely because there are some scary things happening in the world now. I believe these things are redeemable, but sometimes the redemption is not optimized according to the wishes of those who have created the catastrophe. So, of course, things like climate change come to mind. We were talking earlier about the anomalously high temperatures that both poles are experiencing this year. What does that mean for us? These kinds of things have been happening since God was making the universe. In fact, we started with a giant catastrophe we call the Big Bang. So, what made it happen? No one knows. By the way, if you have a comment or a question, you can feel free to, this could be a conversation. This doesn't have to be me blathering to you, okay? So, more than 13 billion years ago, almost 14 billion years ago, there was this huge, unimaginably catastrophic explosion. We don't know what caused it, but that was the act of God creating the universe. In this Big Bang, all of the raw materials for everything that exists was created, lickety-split. There were some chemical elements that got formed first, and then some other ones formed from those. Some of them are extinct. They don't get made anymore. That's how we can figure out how old certain things are, by the ratio of stuff that doesn't get made anymore to some of the stuff that's newer. This big catastrophic event, the Big Bang, must have seemed like an unimaginable maelstrom. And I think about the wisdom of the storytellers who told this in Genesis. And I think, how could they have just made up an awesome story that matches so closely with what we can observe? When you see stories that repeat again and again in different cultures, it makes you think there is a theme of truth, a deeper truth embedded in the stories that is ours to discover from looking at the stories, from digesting the stories, and from asking, what do they mean for us? In the moment of this Big Bang, as the chemical elements were being created, there were hot gases. One of the theories for how you make a solar system, ours, for example, is called the disk solar nebula hypothesis. In this theory, you have hot gases swirling all around, and they rotate. And as the gases are rotating, sometimes the angular momentum of this rotating thing of gas, this glob, flattens it into a disk. And as you get further out due to this transfer of angular momentum, you get more distant from where you started out. When you get further away from the source of your energy, you get cool. Some of the gases began to cool and become solid. And when they became solid, they formed little tiny grains of dust. Well, that dust was still moving in the swirling cloud. And here's the thing. Physics is awesome. Some of that dust attracted other dust. That's gravity, all right? So as you attracted more bits of dust, you began to get, this is a scientific term, a glob of dust. And the dust would start rotating itself, this little glob in the big gas disk. And as you began to get these things coalescing together, they would get bigger and bigger, and as you got bigger, there was more gravity, so it attracted more grains, and they would spin faster and faster. And unfortunately, as they spun faster and faster, they were really hot in the middle. Sometimes there was remelting, and the outside cooled faster than the inside. But the biggest glob would be at the middle of this proto-solar system, is a good name for it, and that would be the star. And that would get so much mass, it would stay hot and gaseous. And these other little globs began to form protoplanets. We like to call them planetesimals. And then those planetesimals would be attracted to each other, and you'd get bigger globs rotating, 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 and also rotating around the central star. And then they formed planets. Now here's the thing. Depending upon how far away the planets are one from another in this distribution of spinning stuff around a star, they would either be at a good spot where they could be captured by the gravity of the central star, or they'd be too small and they'd fling themselves away. Sometimes some other kind of planetesimal or piece of something would get caught up in this system and be captured, even though it wasn't made of the same stuff, the rotating gases and the grains of dust. That's how we got Pluto. We caught Pluto on a fishing expedition out into the cosmos, and that's why Pluto was voted off the island of planets. I'm fond of Pluto. So I will always think of Pluto as a planet. So anyway, this process is really violent. What ends up happening is you get heating and cooling and heating and cooling, and the outside of a planet cools faster than the inside of it. And so that's the reason why the inside of the Earth is still an inferno, sort of the way we all imagine hell to be, because there's so much pressure, and it's hot because of all that pressure. Now that was a pretty big, violent beginning for a solar system. I'm not going to talk about the fate of solar systems because you'd be here all night. Let's talk about the next big catastrophic size event that affected the Earth, okay? When God was creating the heavens and the earth, God also made the moon. And the way God made the moon was, there was a huge impact. One of these planetesimal type things whammed against the earth, spalling off a big bunch of earth and moving away. The earth got so hot, there was more melting again. And the moon, spinning, 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 began to cool. The earth finally began to cool again. This was only about 50 million years after the earth had formed, which was about 4.6 billion years ago. I know, even older than me. The moon forming event was really interesting because the earth originally was spinning so fast, a day was 12 hours long. That's how long it took to completely revolve. The moon at that time was very close to the earth. And as some of you may know, the moon doesn't spin about its own axis. It just keeps moving around the Earth. Well, what ended up happening is some of the momentum of the Earth and its spinning transferred itself to the moon. And two awesome things happened to redeem this big catastrophe of this big, giant thing that glommed into us. The first thing is it slowed down our rotation, which gives us the wonderful 24-hour day we now have, except for the first day of daylight saving, which I still haven't recovered from. And the second awesome thing that was part of the redemption of this lunar cataclysm is that as the moon began to move further away from the Earth, it created less of a dramatic tidal force upon the Earth's surface. So the moon has stabilized the length of our day. It allows us tidal forces, which are important for something else I'm going to talk about in just a second. And the moon is still moving further away from the Earth. Can you guess what's going to happen as the moon moves further away? The day is going to get longer. I don't think I can work many more hours in a day. So at some point in time, none of us will be alive. The moon will be further away from the Earth. But the point is, through this dramatic, horrible explosion of this impactor to the Earth, we got our moon, which has been a wonderful thing for us. And so that is a wonderful example of redemption of a cataclysm. Let's talk about another one. Now, after the lunar cataclysm, the Earth was coming along and reaching its toddler phase. And some of the big rocks, the planetesimals that didn't end up making planets, were traveling. They were taking a road trip through the inner solar system. We tried to have, a planet tried to form between where Mars is and where Jupiter is. But the huge gravitational attraction of Jupiter and the gravitational attraction of the sun were competing forces, and the thing just couldn't hold together and came apart. So there were all these big pieces. And so there was a time, about 4.1 billion years ago, maybe 4.1 billion to 3.9 billion years ago, where these giant impactors were flinging themselves through what we call the terrestrial planets, Mercury, Venus, Earth, and Mars. And they were cratering the heck out of everything. And these things were essentially deadly if life had evolved by that point. So one of the questions that remains is, when did life actually form on Earth? We don't know the answer to that. And the reason why is because the Earth is a very active planet. And pieces of the skin of the Earth dive down under other pieces of the skin of the Earth. We call that subduction. And so the only pieces of dry land left are things that are younger, that are 3.8 billion years or younger, or maybe some old, we call detritus, relict grains from rocks that are no longer intact. So our oldest stuff is not here anymore. So if there were fossils from the time when life formed, we don't have them, which is a big bummer. But I want to tell you that when all these big things were flying through the inner solar system, leaving all these craters everywhere, if life had formed then on other planets, we don't see evidence of it now. So for example, we study Mars because it's the closest planet to Earth, and because it is our nearest neighbor and we formed at the same time, it's a good place to look to see if life ever formed there, because then we would get a better sense of, are we unique to our planet, or is there life elsewhere? Now, I've had discussions with other people who are theologians, some of whom say, well, God created us in his image, and we are special, and it's arrogant to think that any other life could be as awesome as we are. I don't agree with that perspective because God is amazing, and God can create anything God wants to. So if God made us, God could make others. We should never box God into too tiny a vision, because what God can think of is much more imaginative than what we can think of. So I like to think that if we found life on another planet, we would say, see, it's just more proof of God's awesomeness. But let me go back to this time, this 500 million year window. A lot of people think that's when life began. It is a possible window of opportunity when life could have happened on Mars, but the thing about Mars is it's only a little more than half the size of the Earth. And so with so much destruction, these giant hunks of planet hitting Mars, it was a bad day. And Mars lost its magnetic field, which protected its atmosphere from the really dangerous galactic cosmic rays, which are ionizing radiation, and protected the atmosphere from the solar energetic particles, which are also radioactive and very energetic. And so what ended up happening is when Mars no longer had a magnetic field, it lost its atmosphere and the gases escaped. So now Mars has only a thin atmosphere. But most importantly, Mars cooled a lot faster than the Earth did after this bombardment. And so it lost its ability for the planet to be dynamic, for the planet to continue to have volcanoes, and for the planet to continue to have what we call plate tectonics, which essentially means pieces of land going up and building mountains, or pieces of land, one sliding under another, or sliding by each other. So Mars is a very quiet place. There are some very gentle Mars quakes, but it's not like Earth. So Mars, at this point, hasn't given up any information whether or not life ever formed there. This late heavy bombardment has left us evidence. How do we know it happened? Well, there's craters all over the place on Mars and Venus. Can't really see the surface, Mars and Mercury. We can't really see the surface of Venus because it has such a thick cloud cover. Where is the evidence on Earth? Well, if it's older than 3.8 billion years, we wouldn't be able to see it. So, how do we know then that the Earth was affected? We know because we see evidence of it on the moon. And the evidence on the moon matches the timing of when this happened. And if you'll recall, the moon and the Earth are a duo. So that's our evidence of the late heavy bombardment. So what could be possibly redemptive about that? Poor old Mars really got bitten. What is redemptive about the late heavy bombardment is because a lot of material came in with those planetesimals. A lot of materials came, water, ices, other things like that. But most importantly, one of the things we've learned from watching how the Earth evolves is that every time something really awful happens and frustrates what's been going on, we get a big, like a bloom of a flower garden, only it's a bloom of all kinds of life. We call that a big speciation event. So the late heavy bombardment is one of the things that has shaped the solar system. The next thing I want to talk about is something that happened sometime after that, we don't know when, or maybe before and it survived, and that is the emergence of life. Now, I realize that's sort of self-aggrandizing to think about the emergence of life as being an important event, but I'm glad I'm here. I hope you're glad you're here. So the next thing that happened on Earth that's really noteworthy is God created life. And one of the things that happened, this life, we don't know whether it originated in the water or whether it originated on the land. But remember that thing about the moon and the tides and all that? It is possible that life originated at deep sea vents, because that is a place where a lot of interesting gases come up from inside the Earth, and there's a steep temperature gradient, and so you can actually maintain a fairly clement environment without predators to get the chemistry going to make life. It's also possible that life originated on, say, tidal flats, where water periodically washed things onto the land. We don't know. We have a lot of theories about it. But here is the important thing. When life started forming, there was no oxygen. It didn't have the stuff to breathe that we have now. God was able to redeem what we would consider to be a pretty toxic atmosphere, and the first microbes started essentially breathing rock, breathing dust. And the way they did this is they would take in something that had an electron, and then they would take that electron away and make their metabolism be sort of a business, buying and selling of electrons. That's how the metabolism of some of these microbes worked. Well, the interesting thing is, some of the poo of this early life was oxygen. Oxygen was a poison gas to them. Unfortunately, it was a bad day to be a lot of these microbes, because a lot of them died because of the poisonous gas, the oxygen. On the other hand, that oxygen has come in really handy for many of the types of life we have on Earth, including us. So the redemption of the poison gas episode is it allowed other life to evolve that could use that oxygen. It was an awesome redemption of this splooge of toxic gas, oxygen. All right, what's next? So we got life. Then everything was going along swimmingly, but unfortunately, we started to get these really weird cycles that we call snowball Earth. Snowball Earth is a theory that there have been repeated cycles in the evolution of Earth that we had absolutely catastrophic freezing over. Every piece of evidence that shows us that we had a climate cycle where we had this catastrophic freezing over, afterwards, there was a radiation of more life. So it's almost like if your bulbs don't get cold when you plant them, they don't flower. It's like that in the broader concept too. After the Earth got really, really cold, some things died off, some things came back, but new things emerged. God has always had an amazing way of making new stuff out of old stuff. Why does God need to make new stuff out of old stuff? It's because all of the chemical elements that exist, in other words, all of the building blocks, all of the raw materials in the universe that make everything is a limited set. No more of that stuff is made. God made it at the Big Bang. So how do you make new stuff? Resurrection. So that's why we have to have death, and that's why we can keep making new stuff, because that's how God redeems already used chemicals to make new and even more awesome stuff. Well, maybe the dinosaurs might not have been that awesome to encounter, but I think they're pretty cool. So we got a whole new set of life after these snowball Earth episodes. What's the evidence that we did have these snowball Earth events? We have certain types of rock that form on the top. And I'm not going to go through all the nuts and bolts of that because that would make this discussion way too long. But we do have geologic evidence of it, and we see in the fossil record this radiation of more life. So let's move on. What else? Here's a really bad one, and also it's a really awesome one. The invention of agriculture. Now, if I were showing you the slides that I typically show when I talk about this, you'd see giant pictures of cow faces, and you'd see a list of all of the first crops, and that starting about 12,000 years ago, some things began to be domesticated, and then other sets of things, about half the distance between then and now, say 6,000 years before the present. The invention of agriculture has allowed human culture to flourish because the energy that was put into trying to find food was a significant amount, much more than the energy that it takes to domesticate products, agricultural products, and raise food, and that allowed us to develop culture. We began to have some leisure time. We began to have a broader set of things we could do when we could grow our own food. And also we could have a more dependable supply of food. That's pretty awesome. But the invention of agriculture created some really big problems, particularly cattle production. What are the really big problems? Well, first of all, massive amounts of acid rain. Some of this is from the fertilizer associated with creating feed to give to the cattle. But the other problem is one of the most notorious greenhouse gases, which are essentially trapping the heat that we give off from the earth, is something called methane. And methane is a waste product from the gastrointestinal tract of cattle to a very huge extent. So agriculture, while it has been wonderful for the food supply, has not been so good for the temperature supply. The Earth has undergone many cycles of climate change, but we need to think about the fact that our evolution has been during a cycle where the climate was optimized for our existence. What do we do if we turn the climate in a direction where it accelerates the pace of change to an extent that we can't survive it? It is a thing we have to think about. How would we mitigate it? So agriculture was good. Agriculture was potentially bad. How will that be redeemed? I don't know the answer yet, because I get to these more contemporary events, we haven't necessarily seen where they're going to go yet. But I'm going to give some suggestions, and I'm going to take your suggestions when we get there. All right, the next catastrophic event, the Industrial Revolution. Why would the Industrial Revolution be a catastrophic event? Carbon. So the Industrial Revolution has been a problem because A, it creates a different kind of waste than can be largely metabolized by biology, although there is some biology that can metabolize, for example, mine waste. But yes, the use of fossil fuels has become another contributor to the climate problem. Also, the Industrial Revolution has created more direct heat because we started off releasing steam, releasing carbon dioxide, which also is a greenhouse gas, creating sulfur gases as a part of the industrial process of coal burning, making it even warmer, and creating more industrial waste. So for example, when you're driving along a rural road and you see an old family farm and you see a big rusted out tractor, imagine that rusted out tractor as just one of a gazillion mechanical devices that had to be dealt with in, for example, London. So the amount of pollution that despoiled the soils, the atmosphere, and the waters is significant from the Industrial Revolution. Now, it has been a wonderful boon for us to use technology so that we can make our lives more productive. Many would say much better. I love my iPhone, and I love all kinds of things like this adaptive technology, without which you would be a big blur. The problem with the Industrial Revolution is we didn't put any controls on it. So we don't know all of the potential outcomes yet. Can we create new technology to redeem that technology? Of course we can. We're made in the image of God. Why are we here if not to be the redemptive agents of God when we do things to this planet? So now, let's talk about what's coming next. What can we do to redeem climate change? I don't mean what can we as humans do to redeem climate change. I mean, what can we as a church do to redeem climate change? What can we do? Or what should we do? What's your opinion? Pray, well, yes. But we should do that early and often about everything. Any ideas? Sorry? Recycle. Less paper. Less plastic. Anybody see that news item in the last couple of weeks about the microplastics in your blood? It's kind of gross, isn't it? It's going to make me think twice about what I put my water in. So there are lots of things that I think we can do. Climate change is coming. It is here. It is irreversible. It is too late to stop it. What can we do? Well, first of all, we have to understand that climate change disproportionately affects people who are poor. It also disproportionately affects people who live in urban areas because urban areas create their own climate. It's called the urban effect. And it's because of the impenetrable surfaces of the roadways and of the buildings and so forth, and plus contemporary architecture. There's a lot of glass, sometimes even mirrored, reflecting heat back and forth everywhere. So we have to think about how we design buildings, but more importantly, we have to think about what we as a church can do to relieve these super hot days, which we're seeing increasingly more of. So as an outreach and mission of churches, we can certainly become cooling centers. Churches can be conscious of their HVAC systems and have a generator that at least keeps one parish hall or some room at a cool temperature and invite the neighborhood in. Churches can also, we think of winter relief, providing places where unhoused people can go when it's really cold, but we don't typically have summer relief when we get the anomalous 103-degree day. As it becomes humid and it becomes hot, it can become lethal for people. So churches can play a role by their outreach efforts in just providing cooling centers. The other thing we can do is, we're Episcopalians. We believe in reason in our interpretation of the scriptures. And through that same reason, we can also, as one of our marks of mission, think about how we can educate people with respect to newer technologies, which may ameliorate some of the effects of global warming. But most importantly, we can also educate people about new techniques for vertical gardens, indoor planting of crops, addressing agriculture in such a way that we can avoid despoiling more land, and we can control the pollution that goes into the nutrients that feed those vertical gardens. Most churches have more indoor space than they're presently using. It's no mystery And it's no surprise that many, many churches have less members than they used to in the 60s and 70s. This is documented effect. But that doesn't mean that we're less useful. If we can change our idea of how we can serve God, we can become part of the redemption of some of the cataclysms that are to come, some of which are human-caused, some of which are not. But we are made in the image of God, and we know that the dust is always redeemed. And we know that we are Christ's hands and feet on the earth. So it's a very exciting time to be us, because we can effect solutions that will help, that will take care of people when we are in stressful times. We can be a resource. We can have an internet hotspot in our gardens, in our parish halls. We can have resource libraries. How can we age in place? How can we do better, greener agriculture with, say, permaculture and indoor gardening, vertical gardening? How can we do all kinds of things? How can we not do these things? If redemption is helping not only the people, but the entire planet redeem a bad event, could it possibly be? Could we ever say no to God asking us to do that? I mean, let's face it, God created Caltech. God created UNC. I know, we think we created all these universities, but... So there's a lot of potential that we have as human beings, as people of faith, and as responsible stewards of the planet. It's far too early to give up on the capability of humans to do awesome things, just because sometimes we see them doing less awesome things. So I invite you to think about that, and I invite you to ask me any question you want. I will tell you that if I don't know the answer to it, with respect to astrobiology or planetary stuff, you can write me, and I will answer it as best I can, or find somebody else who knows the answer. My email is really simple. It's babeofscience@gmail.com. I have about 90 emails, but that's the easiest to remember. So, who has questions? How does the Ice Age fit into all of this? So we have a number of climate cycles that have occurred that naturally heat and naturally cool. We even had a period of cooler weather called the Little Ice Age that has been documented in a lot of our culture across Europe in the 19th century. And we have these cycles just as shortwave events and longer period events. We call these Milankovitch Cycles. But we have other things that occur too. So for example, when we have big volcanic eruptions, they cool things down because they put a lot of dust in the air and there's less insulation. So ice ages may come and ice ages may not come in our lifetime. The biggest crisis that we have to face right now is not what we would do in an ice age, but what we would do in a hot age. But we should ask ourselves what we would do if we reached a climate crisis of the cold variety. We would have to do the same thing, dig in and think about how we use our technology and our understanding of heat transfer to make life more livable for the least among us. It's our job. I'm not sure I'm understanding what you're asking. Can you ask it a different way? Uh-huh. Okay, that's it. What a great question that is. So just to make sure that you all can hear what she was asking. She said there's one theory that the Big Bang is part of a cycle. One of the theories, so first of all, let me just say the Big Bang is a theory, okay? And here's the dirty little secret of science. It's all theory. It's all models. And when we discover that the models are not as good as we thought they were, we come up with new models. So I just want to put that out there. Now, what we think about the Big Bang is that it is still, so I can't say that we can see back. We don't know what happened, but we can see the trend of heat loss. And you can see something that is warm that we think is leftover energy from the Big Bang called the cosmic microwave background. And we don't know whether it's a cycle of expand, 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 and then contract, and then do the whole thing again. We don't know. There's another theory that it's not just one universe, but that it's a multiverse. I can barely wrap my head around that one. So we don't really know, and we cannot see back. What we can see is radiation that leads us to form the model of the Big Bang, but we can't see the Big Bang. So, yeah, how do we know? We don't know. It's a model. Yes? So the question is sort of related to the last one. He said he's heard that the universe is still expanding, and we can see that from some of these spectroscopic measurements. And then he said, is it ever going to reach a point where it begins to contract again? So that is one theory that people have offered, is that it'll get to some maximum, and then it'll just start falling back in on itself until there's so much mass and so much stuff glommed together that it has another Big Bang. We don't know. Yes? So the question was, would there be a pause in climate change? I'm assuming you're meaning in specific global warming. Right. Okay, so the problem with the heating now is, as we've seen the trend, so say something is going on a slope like this and it's getting more and more and more. But then, suppose you've seen it going like this, and then it starts going like this, and then it's going really, really fast. We haven't seen it look like it's going to pause. So that's what's a little bit scary. So the best thing to think about right now is trying to do what we can to halt the continued emission of gases into the atmosphere that would only exacerbate that problem. There have been some wild ideas that we call geoengineering to, for example, do the thing that a volcano would do and spew a bunch of particles into the atmosphere. The problem is everything is a system. And so systems suffer from unintended consequences, and we're just not that good at understanding the complexities of a giant natural system. So people are afraid to try something like that for fear that we will do something really awful. What we can do is, that first part about trying to use less of the gases that we know are culprits, because we can track the relative percentage of carbon dioxide in the atmosphere versus the relative increase in temperature. So that is a slam dunk. When we talk about the carbon footprint of things and reducing our carbon footprint, I want to clear up something about that. You are made of carbon. So unless you get rid of all the life, you can't reduce the carbon footprint. But what happens is when you use carbon chemicals to release waste products from your use of them that trap heat, what we're really trying to do is reduce the amount of certain types of carbon compounds that are in the atmosphere because they make it hot. So we can't get rid of using carbon. We can stop burning fossil fuels because they release a number of different gases that can make it hot. But we can also think about how do we mitigate it. Right now, in my opinion, the biggest threat we face is, everybody familiar with the term the Gulf Stream? Any fisher folk here? So the Gulf Stream is really important for a number of reasons, but the most important reason is it sends the warmer waters up in the Atlantic, making the United Kingdom habitable. The United Kingdom would be pretty cold. It's at a pretty northerly latitude. And so that's why they can grow stuff in the summer. And it stabilizes the climate on North America, too. Well, there are signs that it is becoming unstable. And if it stopped, then the important role of the oceans in making the atmosphere be, more stable is going to create giant zones of freakishly cold weather in certain parts of the East Coast, like down to here, and England would be extremely cold. It would be essentially like Svalbard. So trying to think about what we're doing to increase the temperatures of the oceans as well is equally important. So those are just a couple of things, but I don't see a pause. Yes? Okay, thank you. Great question, and I'm going to try to repeat it, summarize it to make sure everybody can hear through the microphone. So it was, how does my understanding of redemption from the science part of me affected my understanding theologically of redemption, and how do I use that in my ministry? Is that a good, okay. So my whole thought about what happens scientifically with redemption actually came from my theology of redemption. And what prompted that was when I was in seminary, I had an assignment to write a paper in my class on Christology, which is, what is our understanding of Jesus? And I began thinking about how it really bothers me when we only talk about the meaning of the cross and we don't talk about the meaning of his ministry and his life. And I thought that as an internally consistent, fully incarnate God in human flesh, then there's got to be some important lessons about redemption from his ministry and life, as well as from his crucifixion. So for me, obviously, the redemption of the crucifixion is the resurrection. But Jesus redeemed the way that people regard one another by, for example, his treatment of the Syrophoenician woman. He expanded his notion of who was his neighbor when she said, well, even the dogs get crumbs, and he said, oh. And he said, wow, your faith is pretty impressive, may it be so. And so what I learned from that is that Jesus' ministry has taught us that there's redemption everywhere, and that there is resurrection everywhere, and that as sentient beings, our job is to look for the redemption in everything. Not that it's easy to see all the time, especially when bad things happen, but what I can say is that thinking of redemption more broadly than only salvation from sin, or thinking of redemption more broadly than what happened when the stone was rolled away and Jesus was resurrected, gives me a comprehensive sense of every minute as the possibility of redemption. And I think that that is what gets us through tricky situations. So for example, COVID, not a whole lot redemptive, about 70,000 people who died in our country alone. But what I will say for the church, the redemption of having to be unable to meet in person for a while taught us that we could connect with each other all the time through other means. And people who had been afraid of computers before, at least in my own parish, became very responsive to their use. And we were able to redeem the loneliness of the isolation by the connection and the worship, the Bible study, the mission, all the things that we could turn around and still do, redeemed a time of trial into a time of potential. So that's one example. But I think the most important way I could answer your question is to just say, now I just see redemption everywhere. And it took a long time to get to that point. Yeah.
So over the past several decades, we have seen amazing things happen here from outer space, like from the Hubble and from the things that you've worked on. What's the most exciting thing that you see right now that from space exploration really is turning pretty clear? Something that's really exciting that you see that's coming to us.
I think it's all so cool. It's hard to pick one. I'm going to give you an answer you probably are not going to expect. Of course, all of it's cool. And I really think that what is interesting about space exploration is that we are about to become an interplanetary species. And the thing is, the way organisms radiate out into other environments, sometimes those environments are not habitable yet. But the existence of people in those environments can make them habitable. On the other hand, the human history, unfortunately, as instruments of empire and far too often colonialist, makes us take pause and think about what does it mean to be a post-colonial explorer, and think about the universe not as a place to exploit, but as a place to reveal the glory of God. We haven't quite gotten there yet, not even on Earth. We have a lot of homework in that regard. But here's the thing, all biology is colonial. And so that part is hardwired. So the question is, if we are made in the image of God, is that the mitigation for a tendency to be colonial? I think it is. I think we just haven't quite gotten that yet. But to more directly answer your question, which is what is the most amazing thing that turns me on? So I also had an opportunity to explore the deep sea hydrothermal vents from a submarine, from a deep sea submersible. And what was the most amazing thing was at the bottom of the Pacific Ocean and the bottom of the Sea of Cortez, which I also got to go to, you could, when you turn on the lights on the submersible, you could see the place was teeming with life. There were fish with eyes. There's no light down there. Why do they have eyes? What that must mean is they exploited that environment and moved there. And what you could see is as hot gases came out from these hydrothermal vents, the black smokers, you would see a succession of life. It's very, very hot. Some of them are super hot, but the ones that I saw were relatively not quite so bad. They were like 60 degrees Celsius to 100 degrees Celsius, almost to boiling. As soon as you get a little bit away from the vent chimney, it gets relatively modest temperature, and then when you get this far away, it's back to the 2 degrees Celsius that ocean water is. But there was tons of life. There were tube worms, there were shrimp, there were these little crabs, tiny little octopus, and big old fish. And what are they doing down there? It's awesome. And that really made me appreciate how tenacious life is, and that our job is to be as tenacious as these other species without being colonial. Yeah. Okay, the question was, how does what I think about the way things have evolved and my theology either contradict or coexist with Darwin's theory of evolution? So first of all, I commend to you this amazing book by the late Chief Rabbi of Great Britain, Jonathan Sacks. It's called Morality: Restoring the Common Good in Divided Times. He has talked about Darwin often, and he also talked about Darwin and a kind of contemporary, Alexis de Tocqueville, and talked about the origin of species and also the origin of cultures and politics and things like that. So there's a great discussion in there about where Darwin fits in with theology. And what is so interesting to me about my cosmological view and Darwin is that we cannot expect that Darwin had the complete set of observations of all life on Earth or molecular biology. But what we do know is that he didn't have the molecular code that makes the instruction set for life. What he could do was observe from what he saw. So Darwin and I are doing the same thing. We are taking what we look at and trying to come up with an understanding. Do things evolve over time? Yes, they do. And the reason why is because that's how they adapt to changing conditions. And so that's brilliant. God created evolution because God wanted life to be able to adapt to changing conditions, which I think is a brilliant fix for keeping life going on the planet. But Darwin's idea that everything is about competition and survival of the winner, so to speak, I don't think that that is always the right way to view it, because the winner on a species basis is different than the winner on an individual basis. And what we also see in evolution is symbiosis and mutualism. And in fact, there are many examples where life forms collaborate to create an environment that works for them all. Microbes are rarely found just as one. They live in consortia, in mixed community. So there are some things that I think are very profound about understanding that life evolves, because life should adapt to changing conditions. And I don't see that as much of a disconnect with the general theory of events that happen in the arc of time, and they are redeemed by the adaptation that happens as a consequence of that. Yes? I think about stuff like that all the time. I have no clue, but yes, I will. So the question was, there's a detailed record of the writings of John from the Isle of Patmos about a new heaven and a new earth. And what do I think that looks like and how that's going to happen? And my initial answer is, I don't know. But I think that it's probably that my imagination isn't big enough to think of what it is going to be. But usually when I talk to people about this, we kind of get caught up in the discussion of, is there going to be bodily resurrection or spiritual resurrection? And I can't get people to think beyond that, is it body or is it spirit? So the short answer is, I don't know. But it's going to be awesome, whatever it is. Do I think it's coming soon? There have been signs of the apocalypse always. And there's also signs of redemption always. So I don't think of eternity in the context of forever. I think of eternity in the context of dimensionless, meaning not measurable. And what that means is that in my pea-sized brain, it's not guessable either. But that doesn't stop me from trying. I've got no clue. Yes. A good book on climate change. A scary one or a factual one? So most of the things that I read are like not an easy read. They're just lots of charts and graphs. But I think that one of the seminal ones that was written for everyone to digest that doesn't have necessarily a climate modeling background was the book that Al Gore wrote like 20 years ago, An Inconvenient Truth. The books since then, there are many. National Geographic has a few on climate change. But most importantly, before you read a book on climate change, just to read a general book on meteorology and climate and geography is important to understand how those systems intersect, because the climate change literature makes no sense unless you have this sort of basic knowledge of the complexity of the system, which is why it's so hard to figure out how to make any mitigation. Yes? So the question is, historically, there has often been a conflict between science and faith. And why does that happen, and what could we do? I do sometimes experience it. But I can't tell whether it's sexism or it's science and faith. But I think historically, people tend to not multitask well. So they think you can either be this thing or you can be this thing, and that they shouldn't work well together. So there was a really cool guy back in the 19th century who wrote a book called The Church Idea. His name was William Reed Huntington. And he was a scientist. He was a chemist. And he went to my seminary, which was at the time called Episcopal Theological School. And he used the way nature is arranged, how biology works, to try to think of a good structure for ecclesiology, for how the churches should be arranged. It was essentially why a sacramental church should be designed like the way this particular sacramental church is designed. He was around the contemporary of Darwin, but he didn't refer to adapting to change, and some of his things that he thought about biology were not quite right. But he was a man who tried to use what he observed in nature as a model for what the church might look like, which I thought was a great idea. He came up with the seminal ideas that formed the basis for the polity of the Anglican Church. So he was a really cool guy and very ahead of his time, using science and faith together. Why we have arguments for that right now, I honestly don't know. I scratch my head over it. It may be because some people take the Bible as more of a literal, factual manual as opposed to a deep well for theological reflection. And I think we have an awesome collect in the Episcopal Church that Verna Dozier quotes. And that collect basically thanks God for creating the scriptures for our study, and how wonderful it is to look at them and inwardly digest them, and that God caused them to be written for our learning. God did not cause them to be written as a checklist. And so I think some of the issues that people have between science and faith may have to do with thinking it is a desecration or a sacrilege to consider the Bible a well of spiritual and theological reflection as opposed to a more literal, dictated manual. My position is I have never gone to the Bible to learn something and not come away with something. So I think it's, awesome. But what I do know about people who have an issue between science and faith is that once again, we sell God short. And if we want to know more about God and more about the things that God made, why wouldn't we use every part we have? So I, for example, would not just shut my eyes and listen to bird song. I would like to also see them. And so the same thing with head and heart. Why would we only use one of them? That just seems nuts. So don't know the answer why that schism has existed. Yes. The question is, what might we expect to learn from the James Webb Telescope about the origins of the universe? Well, first of all, the Hubble is aging, as awesome as it is. And secondly, it has a broader field of view. And so we hope we will be able to see further back in time, because the farther we see, the more light we're collecting from more distant events. So what will we learn? I don't know, but the more data we collect, the more we have to put into the pot to stir our ideas. So one thing that intrigues me that I don't really think that James Webb can tell us is, what the heck is dark matter? I don't know what dark matter is. Some people think it could be like organic matter. I think dark energy is God. So my name for dark energy is just God, and that's how it is, because if God created the universe, that means the universe is sitting in God, which to me means the energy of God, which is love, is what makes everything move. And because everything is moving, that means it can form new relationships, and as it forms relationships with other matter, it moves in a different behavior, and it means there's infinite possibilities for redemption. So can James Webb show us that? I sure wish, but I'm guessing no. The questions are slowing down. Did you have any questions? No? I didn't want you to think only grown-ups get to ask questions. Grown-ups are only so-so. The question was, so there are some areas of Earth that are sort of kept by scientific consensus pristine. And one example is the Scientific Committee on Antarctic Research, called SCAR, amongst folks who go to Antarctica. So the question is, would there be a possibility that something like that would be the case for Mars as well? So there already is something like that called COSPAR, and I'm always forgetting what the acronym means. But anyway, COSPAR is a multinational agreement about things like not contaminating places we're exploring and not backward contaminating us by bringing things back that are not protected so that we don't create another cataclysm on Earth. So we have these agreements in place, but the problem is the same problem that we have with Antarctica, which is that the signatories to these treaties often interpret them loosely. So sometimes people think this particular thing does not apply to us. And so even Antarctica is becoming slightly less pristine than it once was. But people are pretty good about trying to at least preserve the science for observation, but I think that that's a time-limited thing. Mm-hmm.
Which I think brought his interest in politics and his devotion to faith together in powerful unison. And here in this church, he said that he had lost faith in institutions like the presidency or the Congress or the courts, additional institutions or change to have any impact on the problem of the climate, the environment. And he said finally he thought that the only institution that could make a difference is the church. I wonder whether you could comment on that. What do you think the potential for the church, our church, the Episcopal Church in particular, but the church in general, to have the will and the ability to bring people's attention to the problems of global warming?
So the question is, sort of to loosely paraphrase, to the sentiments of Jim Wallace, who I think is awesome, by the way, has said that he has lost faith in political institutions to bring about large social change. And so the following on question was, what about the church? And so let me respond to that by saying amen. That's the first part. The second part is that one reason why I love the Jonathan Sacks book on morality so much is he talks about this. And the thing about, one of the things he talks about is that political entities or the state, nation states or smaller states, exist on the foundation of power. I would like to say that the church doesn't, but it does to some extent. But churches or faith institutions in the general sense and civic associations do not exist on the basis of power as much as they exist on the basis of the common good. And so when trying to think about those institutions that would have a vested interest in, for example, restoration of the climate to make the Earth a more livable planet, I think that it is the church's job. The body of Christ is more interested in this than, sadly, any financial institution or political institution, because we are willing to cede the power to God and think about the people, because it's not like a piece of IKEA furniture where sometimes there's an extra part. It's all the parts are necessary for the body of Christ. So I think the church is particularly well suited. And as a matter of fact, I think it is an ecumenical effort that all bodies of faith are much better suited for addressing the climate crisis and other types of things like that that affect the common good, because the church is concerned with having the moral imperative of keeping a common good. That is the basis of how we get along. The basis of how political institutions and nation states do or do not get along is their maintenance of power. Now, unfortunately, we're kind of trapped in the economics of capitalism, because pure economists say that you should not regulate capitalism for it to work. But unregulated capitalism becomes married to political institutions, and then things have the moral imperative to fix something becomes less consequential than the economic imperatives to keep you from fixing something. So there's a standoff. So the church can be a leader in not only responsible stewardship of the planet, but how can we have a more just capitalism? We're all participating in it. I have a 401k. But I think that we need to learn to do it slightly differently so that the economic imperative doesn't trump all of our important other social reasons for keeping the earth livable. There's a lot of promise. I think we're missing that as an important ministry that we could do. Anything else? Yes. Oh, that's a great question. So he was saying that, we have a pretty good record of how Christianity has evolved over time. Anybody here ever read that 3,000-page book by Diarmaid MacCulloch that we all who took EFM have read? That is a humongous book. Anyway, that is the best book I've read that sort of gives the whole thing. I've also read another book that is a work of fiction that tells about the story of the spread of Christianity in Asia, which is really interesting. But the thing that I want to say in response to that question is this. I don't know where the institution is going to evolve to, but one of the things that I think is that we are seeing at a moment in time where more people are in this country declaring themselves what we have known as this sort of trope, spiritual but not religious, that people are looking for something that the church must not be giving them. And so I spend a lot of time thinking about, okay, what can we give people that they're not getting in the building? I think one thing that we can give that people are not getting from Facebook is a more unbiased view of current events. We should not all agree with each other in church. What we should agree to is to be civil and to be loving to one another, regardless of what people think. It's really hard sometimes when we feel personally threatened by somebody else's point of view, but that's one thing we can do as a church. The other thing we can do as a church is begin to think about the role of church in forming the moral foundation that allows us to have a common good and a civil society as opposed to just a bunch of competitors in society. My personal feeling is we need to get back to the model of the Celtic monastic community. Not that we should all go live in monasteries, but what I mean is the architecture of a Celtic community, it was a planned community. And at the hub was the faith center. And everything radiated outward from that in a big circle, including the agricultural lands, the technology that supported that, the individual the places where people live, the houses and such. We need to think about that. Now that we have cars, our parish attracts people from, 45 miles away. That's somewhat problematic. Not that people shouldn't go to the church they want, but we could do a lot better at living in community with one another so that the church is always there to support. So I don't know where we'll end up. That's where I'd like to see it end up. I love church, but obviously, we'll have to just see. I don't know where it's going to go. I don't think it's going to die, though. The institution might have to die so it can be resurrected, but the body of Christ isn't going anywhere. Yes. Okay. Sure. What he was asking was, would I please restate that notion that if the universe resides in God, that it is the energy of God that gives rise to everything. And so that means that that redemptive energy must be love because we have decided that God is love, which, I mean, is, I think, obvious. But so here is the notion. We know that everything that exists moves. Everything that is alive moves, or everything that we consider to be inanimate is always moving. We can measure these vibrations with different kinds of scientific instruments. We also know that as you move, you give off heat, you lose energy. And as you get together, you pick up energy. As you get further away from the source, from the love, from the dark energy, from whatever you want to call it, from God, you get colder. The only thing that is absolutely still is something that is at the computed temperature that we call absolute zero. We even define absolute zero as the temperature where everything stops vibrating. We cannot make absolute zero. We can try to get close. So what I'm thinking of is the absence of God is death. And what that must be in terms of true death is no more movement. When you live in God, God redeems everything by the possibility of new relationship. And the proof of that is that everything moves. So this is my theory, okay? So it's possible I'm full of baloney, but this is what works for me. You're welcome. You're welcome.
Pam, thank you again for your time and your presence here with us this evening. I thought I might close with a prayer.
Awesome.
Good word. From the prayer book. This is in the context of prayers for the natural order. The Lord be with you. Let us pray. Almighty and everlasting God, you made the universe with all its marvelous order, its atoms, worlds, and galaxies, and the infinite complexity of living creatures. Grant that as we probe the mysteries of your creation, we may come to know you more truly and more surely fulfill our role in your eternal purpose. Give us wisdom and reverence so to use the resources of nature that no one may suffer from our abuse of them, and that generations yet to come may continue to praise you for your bounty through Jesus Christ our Lord. Amen. Amen. Thank you again for your time tonight.
Thank you.
Thanks all of you for being here.